Hello everyone, this is the second part of the tutorial on vector containers in C++. In the first part of this tutorial, I explained you how to write the code that you can see over here. First of all, I explained you how to declare vectors in C++. Then I explained you the meaning of this function pushback, namely this function is used to add entries at the back of vectors. Then I explained you how to print vector entries by using two approaches. The first approach, and the corresponding function is given here. This function prints the vector entries by using the classical or array style indexing. Then I explained you how to use iterators in order to print vector entries. And finally, I explained you how to access vector entries and how to print the entries individually. Before I start with the second part of this tutorial, I would like to mention a few things. First of all, I created a post that nicely summarizes everything that I will explain in this video. A link to this post is given in the description below. Secondly, it took me a significant amount of time, energy, and planning to create this video tutorial. Consequently, I kindly ask you to press the like and subscribe buttons. Thank you very much. Okay, so let's continue with the second part. Over here, we declared a vector of integer type whose name is vector1. Over here, we use the member function pushback to fill in the entries of this vector, and consequently this vector has the following entries: 15, 20, 2, -1, -10, -5, and 25. 25 is the last entry. We can obtain information about the vector1 size by using this member function .size. So let's comment this part of the code over here. And let's compile and execute the code. So vector1 size is 7. And that's correct, because we have 1, 2, 3, 4, 5, 6, 7 entries. On the other hand, over here we declared a vector of integer whose name is vector2. And the size of this vector is 5. Now, let us print this vector. We can print this vector by using this function print vector iterators that's defined over here. Compile and execute the code. Okay, so going back to our declaration, we can immediately see that when we specify the vector size, in this case 5, in the declaration, the compiler will automatically set all the elements to 0. This is very important to keep in mind. We can resize vector2 by using the member function resize. Over here, I will resize the vector and I will print its entries. Let's see the result. Here's the result. Previously, vector2 had 5 entries, and now vector2 has 10 entries. And you can see that all additional entries are set to 0. And that's very important to keep in mind while resizing the vector. The compiler will fill zeros while resizing your vector. Keep in mind that thing. Now you can interrupt me over here and you can say the following. Well, I don't like the fact that the compiler is using zeros to fill in all the entries of vectors while resizing. Can we somehow control that number, that fill-in number? And the answer is yes. So over here, I will specify the number to copy, that is, I will specify the filling number. In my case, it will be equal to 2. And I can basically overload this function resize, and I can use this version of resize. The first argument is the dimension of the resized vector, and the second argument is the number to copy, that is, the number to be used as a fill-in. Let's execute this code and let's see the result. First I need to compile, then execute. And here's the result. This is our original situation. Then we resized vector 2. It has now 10 entries. And over here, I resized the vector to 20, and you can see the result. This was the original part with zeros, and this is the resized part. And you can see that all the additional entries are equal to 2. In the sequel, I will not need vector 2 anymore, so I will erase vector 2. I will erase this part. I don't need this part of the code also, so I will erase it. And I will explain you how to erase or delete certain entries of a vector. First, let us explain how to remove the last entry. We can use this function popBack to remove the entry at the back of the vector. So in our case, vector 1 has entries 15, 22, minus 1, minus 10, minus 5, 25, and we will remove this last entry by using this member function popBack. But before we do that, let us print this vector by using, for example, this function over here. So I will copy it and I will paste it. We will need to print this vector for comparison because I will need to show you what is before and what is after removing vector entries. So this is our vector 1. Let us first print this vector and let us first remove the first entry from the back. And over here I will simply comment this code since I don't need it at this point. And let's see the result. But before we see the result, I need to print the result after erasing the vector, and I just need to copy and paste this function. So let's compile and let's execute and let's see the result. Okay, so let's analyze the result. These are the vector 1 entries before we erase the last entry. You can clearly see that the last entry is 25. Now we call this function popBack in the code line 61, and as you can see over here, here's new version of vector 1. We don't see 25 here at the end. Consequently, this function works perfectly. Now let's move an additional last entry of this vector and let's see the result. So I will call this function popBack once more and let's see the result. And let's run the code. Okay, so you can clearly see that compared to the original version that's given over here, the modified version of vector 1 is lacking last 2 entries. And this is because, actually these are last two entries, and this is because we use the function popBack. And here's the result over here. Now you might stop me over here and ask me the following question. How to delete an entry at a specific position? And the answer is the following one. You can use the member function erase. In the sequel, I will explain you how to properly use this function. The first step is to define an integer, or better, unsigned integer that defines the position. Then you need to define an iterator. In my previous video, that is in the first part of this tutorial, I thoroughly explained iterators. Briefly speaking, iterators can be seen as pointers to specific entries in the vector. Over here, I define an iterator called vector iterator that points to the first entry in the vector. This function over here, begin, is a member function that returns an iterator to the first entry in the vector. Then, once I have this iterator, I can basically call this function erase, and over here I specify an iterator to the entry that I want to erase. In my case, vector iterator starts from the beginning, and I want to erase my entry at the position 1. So consequently, over here I just specify the position, and that's it. And over here I will print the result. But before I do that, I will simply comment this part of the code. So let us compile and execute the code. And let's stop here for a second and let's analyze the result. Okay. This is my vector 1 before I erased the entry. This is a complete vector 1. Now, notice over here, I want to erase my entry at the position 1. Consequently, I want to erase this entry. And let us see the result. Let us see vector 1. The result is correct. I'm missing here 20. Consequently, this function works like a charm. If you want to erase entries of your vector belonging to a certain interval, you can use an overloaded version of the erase function that's given over here. The first step is to define, or better to say, to declare the size of your interval. In my case, the interval will consist of 3 entries, and consequently that's why I'm having 3 over here. The first argument of the overloaded version of the erase function is an iterator that points to the beginning of the interval. In my case, it's going to just to be vector iterator that's defined over here and that points at the beginning of vector 1. And the second argument of this function is going to be an iterator that points at the end of the interval. Consequently, it's going to be equal to vector iterator plus interval. And let us finally print this vector. Now, over here, I'm going to erase this piece of code in order to make this code as easy as possible to be understood. Let us compile and let us run. And let us analyze the result. This is our vector before we erased entries, and this is the result, or the vector after we erased several entries. Let's analyze this thing. So, our interval starts from the beginning of our original vector, that is, it starts from number 15. It has the length of 3, so we should erase 15, 20, and 2. And as you can see over here, we erased these entries. Consequently, this function works perfectly. Okay, now that we know how to erase vector entries, let us explain how to insert vector entries. For that purpose, we will use the member function insert. And the logic is very similar to the erase function. The first step, of course, is to declare a vector iterator that will point to a certain position. In our case, we choose this iterator to point to the beginning of our vector 1. Then we declare an element that we want to insert. In my case, I'm inserting 1000, and then I can simply call my member function insert. I specify the position at which I want to insert my entry. In my case, it is the second position in my vector, since my vector iterator insert points to the beginning of the vector, and I have this +1 that basically says, okay, I don't want to insert at the first entry, I want to insert at the second entry. And the second argument is the element that we want to insert. And finally, over here, we print the vector. Again, I need to comment this part of the code, compile, and execute, and let's see the result. Here is the result. This is before, this is after. Let's analyze the result. We can see number 1000 at the second position. Consequently, this function works perfectly. We can also use an overloaded version of this function to insert entries, or better to say copies of a certain entry. First of all, we need to define, or better to say declare, number of copies. We will have 5 copies. Then we declare an element that we want to insert. We simply want to insert 2000, and then we simply call the overloaded version of insert function. We specify the position from where we want to insert. In our case, this is the second position. Then we insert the number of copies. Number of copies will be 5. And finally, we specify the element to be inserted. And finally, we plot our vector. So let's compile, and let's execute, and let's see the result. Okay, so here is the result. This is our vector 1 before, and this is our vector 1 after. I can see over here that I inserted 5 entries starting from the position number 2. Perfect. This function worked as expected. Next, I need to explain you how to find an entry inside of a vector. For that purpose, I will use the code that you can see over here. So let's say that I want to find entry 2000. I declare this entry. Then I need to define, or better to say declare, an iterator. I call this iterator find iterator, and I need to use this function find. And in order to use this function find, you need to use this library. Don't forget to include this library in your code. Okay, so let us explain how this function works. This function returns an iterator to the first element that is equal to entry that we want to find. If there is no such element in the vector, the function returns an iterator to vector.end. So, if the specific entry that we want to find exists in the vector, this function will return an iterator to the first element that is equal to the entry that we want to find. On the other hand, if the entry does not exist in our vector, then this function will return an iterator to vector.end. And be very careful over here. Vector.end is not an iterator to the last entry inside of the vector. No, that's incorrect. Vector1.end is an iterator that points to the memory location immediately after the last entry. Keep that thing in mind. So we call this function. This function will return us an iterator, and then we need to test that iterator. So if that iterator is not equal to the iterator that points to the memory location immediately after the last entry, this means that we found our entry. And we simply print the position of that entry. The position is basically defined, or better to say calculated like this. This is our find iterator. We simply subtract from that iterator the iterator that points to the beginning of our vector, and that will give us relative position in the memory space starting from the beginning of our vector. On the other hand, if we cannot find this specific entry, this condition will be false, and then we simply print the entry is not found. Let us test this code. First of all, we'll compile, and let's execute, and let's see the result. Okay, so this part is our vector after this modification over here, after inserting 5 entries, and let's see the result. First entry that matches the search query found at a position 1. Okay, here's the position 1. It's not position 2 because in C++ arrays as well as vectors are enumerated starting from 0. So the entry is found. Let us, for example, choose another entry that does not exist in this vector. Let us say it's 3, compile, execute, and see the result. Okay, the entry is not found. Perfect. This approach works like a charm. Next, I will explain you an alternative approach that can be used to find a specific entry. And in order to make this video as short as possible, I will simply paste my code. The first step is to declare an entry that we want to find. Here I want to find 20. The next step is to declare an iterator. The name of the iterator is find iterator 2. This for loop over here searches for the specific entry. The for loop starts from the beginning of our vector. The for loop will stop when this iterator reaches one memory location after the end of our vector, or after the last element of our vector, and over here I simply increment my iterator. If the iterator that iterates through elements of our vector becomes equal to the memory position where our element is being stored, or better to say, if the value, because this is the dereferencing operator, that is, if the value at the memory location that this vector find iterator 2 points to is equal in value to the entry that we want to find, we break our loop. This means that we found our entry. And here we can create a simple condition that will test this iterator. So if we found our entry, this iterator never reached one memory location after the final entry, and we are successful, and consequently we print the position. Otherwise, the entry is not found. So let's test this code. And let's run it. And let's analyze the result. Here's our vector 1 after modifications. And let's read this result. First entry that matches the search query is found at a position 6. Okay, so the position 6 is actually 7th entry. So it's 1, 2, 3, 4, 5, 6, 7. So here is our entry. Again, 1, 2, 3, 4, 5, 6, 7. Consequently, this function works perfectly. But again, if some of you are a little bit skeptical, let us, for example, try to search for -5. So here I will modify this to -5. Let's compile and let's run and let's see the result. Okay, so the position is 10. This means that actually it's 11th entry. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Perfect. This function, or actually this piece of code, works perfectly. And finally, let us explain how to erase all the vector entries. We can use this member function clear. And let us print the result. Compile, run, and here's the result. Printing the vector entries by using vector iterators, and after that, nothing. Vector 1 is completely empty. Okay, that would be all for today. I hope that you like this video. If you like the videos I create, please subscribe, support, or like my channel. Thank you very much and have a nice day.